Okay, yeah. So, I've been using Linux for a long time. I started in like high school. I just played around with it a lot. I had a lot of fun with it. I started right when Arch switched from sysv or BSD init to systemd. So I was always on the bleeding edge of that. I didn't know anything about Raspberry Pis. I didn't know much about provisioning Raspberry Pis, and I certainly didn't know anything about Kubernetes or Ansible. So this is my pet project. I was working on it for like 8 months, off and on, like in my free time. So I'm not very good at Kubernetes or Ansible. So ask me lots of questions and tell me things that I could improve or tools that you think I'd like. So why should you use Raspberry Pis? They're $35 a piece by themselves, but you have to buy power supplies and SD cards, so they're about $50 a piece. They're very small. So this entire cluster, you can see it. It's like the size of like an Intel NUC. I don't know if you know how big they are. They're like this big and that tall. Those are like they're basically laptops. But you put 5 of those in a stack, it's like this tall. That's way too big. And server hardware is also way too big. I can't run that in my bedroom. These things don't make any noise. There's no fans. So that's pretty good. And you can buy 5 of them. This whole cluster cost me like $300. So that's pretty good if you're trying to run 5 separate nodes. Obviously, you'd probably be better off buying like a regular Pentium processor for $60 and putting together a crappy computer. But that's no fun. So I didn't do it. Other than that, they're not very good. They're slow. They don't have a lot of memory. Their disk is atrocious. They don't have gigabit Ethernet. USB 2, Ethernet and USB share the same bus, so if you have heavy network usage, your USB slows down, and vice versa. They're fragile, not fragile, but like because the operating system runs on an SD card, they're just not meant for operating systems. So they fail, and they don't fail gracefully. It's kind of annoying, but it's $50 a piece, whatever. There are a bunch of other hobby boards, like the Banana Pi and the Odroid and the Rock 64 or something. They all have about the same chips. The Raspberry Pi has a Broadcom something or other, and all the other ones have a Rock chip, which is like a Chinese manufacturer that's, I don't know, but their kernel support is not as strong as Raspberry Pis. Until recently, you had to run a custom kernel on Raspberry Pis, but as of kernel 4.14, all the drivers and stuff are in the main line. So that's why I have the community bullet point there, because you had to run a custom kernel, you had to use the custom Raspbian, which is Debian with all the packages reconfigured for ARM and the proper kernel drivers and all that jazz. But now it's less of a big deal. There's even a CentOS. CentOS 7 runs on Raspberry Pi because of the new kernel updates. So that's why I just stuck with a Pi, even though you get much better value out of some of the other chips. So there was 4 big steps here. I had to figure out how to get software on the Raspberry Pi. I had to figure out how to manage the actual systems, because you still have to do that on Kubernetes. You can't just like magically summon a Kubernetes. And then you got to install Kubernetes, and you got to actually interact with the cluster and get things going on it. So the first step, flashing them. This is what my thing is supposed to look like. At home, I actually have this behind a double NAT. So this is actually another router, and then there's the internet. But that's all. It's super simple. It's flat network. All the Raspberry Pis are on the same level. And I don't know, it's not that complicated. It's all flat. I statically assigned all the Raspberry Pis in my router, and I wanted to try one of the Ubiquiti routers, so that's what I have over here. Got a Edge Router X. I've never managed network equipment before, so that was also something I had to learn. It's hard, and I screwed it up this evening, so it took me a while to get that going. I also bought a managed switch. I bought it from someone on eBay. I don't know, it was used. I wanted to see what it looked like. I've never done it before. I didn't actually do anything with it. It's still a dumb switch. And I have a wireless access point that used to be a Wi-Fi extender. It was also really cheap, and I don't care to get a better one because this was 15 bucks. And I don't have an Ethernet port on my laptop. So I had to get a Wi-Fi somehow. So I already covered one of these. There are a few other operating systems available on a Raspberry Pi. The big popular one is Raspbian. That's the one, if you buy a Raspberry Pi from like the company that makes them in the UK, they come with an SD card with Raspbian on it. It's literally just Debian 9, but with all the packages recompiled, and they all say Raspbian instead of Debian. There's a couple helper scripts included, one that updates the firmware and one that like sets the host name and changes the default user password. They're trying to target education with the Raspberry Pi, so it's all super easy. There was even like an app store at one point, but it got shut down because no one cared. But that was the first option. The second option, which is one I actually used, I don't know how to say it, Hyperion, whatever. Just some random people on GitHub put together a distribution. It's just a repackaged Raspbian, which is a repackaged Debian. It just has Docker CE pre-installed and has some kernel tuning done and some sysctl settings done ahead of time. Install some ease of quality of life packages ahead of time. I'll get into some of that in a minute. But I went with that one because they had a tool that made it really easy to flash SD cards, because that's how you have to get operating systems on these things. And I threw Fedora and CentOS in there. I considered them for a minute because I use CentOS at my day job, and I use Fedora on my laptop. This laptop's Fedora, so I'm interested in it. But it didn't end up working, and I didn't really care to get it working because I kind of wanted to learn new things, so I went with a Debian-based system. LoadOS, and like I said, you got to just you literally get like an image, like an AMI kind of image, like just a disk image, and just flash it to an SD card. Hyperion uses CloudInit to do this. So you put a CloudInit YAML file on the boot partition, and it uses CloudInit at boot time to set, like, I use it to add my username and my SSH key, and basically that's it, because everything else is weird. When I mentioned my cluster staying up for longer than 2 weeks, I figured out that it was actually because CloudInit never finished running, and it would reboot my Pis randomly. So I have to disable that now. I had originally asked CloudInit to update packages and then reboot if necessary, and that was what causing the problem. I didn't care to learn about CloudInit too much. Does anyone actually use CloudInit? Is that still a thing? No? Okay, I don't know. I was super impressed with Ansible the first time I played with it. You just kind of say, Ansible, here's a list of hosts, and then run these code on them. And that's all I really had to do. I just wanted to run like 10 commands in order. So that's all I did in Ansible. I know it's terrible. Greg's already looking at me because he's already looked at the code, and it's awful. But it's bad. I don't know what I'm doing. Yeah, all my code is up on my GitHub repo, Chief Brookie Pi Images. I'll send a link later. And there's going to be a blog post about this next week-ish. I think I have to have it up by Thursday. So it'll be on the onyxpoint.com website. So when it comes to bootstrapping Kubernetes, there is an Excel spreadsheet, a Google Doc spreadsheet, floating around with every single Kubernetes distribution on it. There are literally 70. There's at least 4 different ways to do it in the official Kubernetes GitHub organization. There's like kops and kubespray, there's kubeatom, and there's all the managed ones, GCE, GKE, Amazon, Kubernetes. I don't even know what that one's called. In Amazon?
Yeah.
Why 3?
What is it? It's EKS, and then they have the new one. I don't remember its name.
Okay, whatever. That's a lot.
Yeah.
So I just wanted to run it on hardware. I initially read Kelsey Hightower's, yeah, it's really bright. I originally read Kelsey Hightower's Kubernetes the Hard Way, GitHub repo. Kind of just goes through each one of Kubernetes components and like how certs work, because everything has its own certificate, and all the services have, all the nodes have their own certificate. They all register on the CA and stuff. So I don't have to do any of that with kubeatom, and that's what I wanted to do. I didn't want to manage any of that myself. I don't manage upgrades. I'd probably rather wipe the cluster than upgrade. There's no reason for me to do that. They have a lifecycle interest group where they consider how hard it is to upgrade from Kubernetes 1.10.2 to 1.10.3. So, and I don't know, Kubernetes stores all of its state information in etcd. Like, you can kill Kubernetes anything, and as long as it should have already pushed its state into the etcd data store in the back end. So etcd is probably the only thing that's super hard to update. I haven't had to do that. I don't think kubeatom does it for you. So, fine. So this the only thing I really had to set was the pod subnet, because that tells the networking backend where to allocate IP addresses. And for some reason, it doesn't do that for you yet. You still have to specify it manually. But that's just the value they give you in the instructions. So, works for me. I tried to set auto policy. I don't know if it actually does anything, but I was concerned about wearing out my SD card, so I didn't want to keep any logs. I don't know if it worked. I haven't checked. Yeah, so kubeatom sets up everything. At the end of the day, you show up with something like this. These are all the pods. Everything runs in Kubernetes on kubeatom. So these are all the infrastructure level components. The scheduler is like what puts pods and containers on what nodes and all that stuff. Proxy is what does the networking. Controller manager is, I forget what that one does. API server manages the API. etcd is the storage backend. And core DNS is something really neat. This is where some of the luxuries of Kubernetes start coming out. I'll get to that when I start going over my manifests. But that will be pending until you install a networking backend. I chose Flannel. So there are a lot of problems with ARM. There's not a lot of packages available. Weave says they have a package, but they don't. Every release I've tried doesn't actually have an ARM Docker container. Flannel does, and it works every time. So that's the one I end up using. It doesn't have a lot of fancy features, but I don't need network policy. I'm just trying to learn how to do Kubernetes things. KubeRouter was one I wanted to try because it uses native routes and IP sets and does some interesting magic to avoid running another service or something like that. It's also super alpha. I just read about it and wanted to try it out, and it didn't work either.
So there's zero option to use the actual bare metal routing?
You can if you want, but that requires more configuration outside of Kubernetes.
Right.
Yeah. So this is how you interact with it. So you can just download the example documentation YAML. And I had to edit it to get the ARM images instead of the x86 64 images, and you just apply it. So here's the Kubernetes architecture diagram. Super intimidating. But I wanted to put this up here because of how pods interact with each other and how pods interact with the API server. So a pod is a group of containers. So every container in the pod can communicate over localhost without issue, even though they're separate containers. And every pod is managed by like a deployment or something, a deployment or a daemon set, or something like that. So every node has a subnet. So when packets come to each node, so networking backend, it communicates over UDP, some port, I don't remember which port. All the networking goes over that port over UDP. And so you send it to, node 2 sends I want to get to node 1, so it just looks up, asks Flannel what host that pod is on, And then the flannel says it needs to go to node 1. And then once it gets to node 1, it says, oh, I'm looking for this pod. And then it finds its way there. I'm still super weak on the networking. But it works, and that's fine. It depends on the networking backend. Flannel does use VXLAN. And if you use Kubernetes in a cloud provider, it uses whatever VPC technology they have. Like GCE has their own special one, and Amazon has their own special one. It's all integrated up in there. So I'm on the hardware side, so yes, I remember it now. Okay, so that's kuberouter explicitly used IP sets, but IP sets were unreliable for something. Other essential applications that I had to find myself. This is the part of Kubernetes that I think is really hard. Like you need a load balancer. I had to find one that worked in a hardware environment, and that's apparently not a common place to run Kubernetes. And these are core things that just aren't part of Kubernetes, and it kills me. I don't really know that much about load balancers, but somehow it makes an IP. In my service declaration, all I have to do is ask for a real IP, and I get a real IP.
Okay.
And this IP isn't attached to any hardware. This one is actually written by Mental LB was actually written by a Googler in his 20% time. It's super easy to use. I just deployed it. I just downloaded the YAML file and did a kubectl apply. And now I have magic IPs. Works for me. This is less important things. Well, one of them is less important. Metrics are kind of up in the air right now. I used Heapster for a minute, but that was deprecated as of 1.12. I could have kept it up, but I don't really care for the storage that it took up, so I just left it off. It was down half the time anyway. Heapster was Prometheus data provided by the kubelet, which is where the pods act. It's like the thing that schedules all the pods on the actual nodes. It turns them off and shuts them down and mounts all the storage and all that stuff. That reported metrics to the Heapster server, which put it in a InfluxDB database that was too big. I didn't care for keeping a gig of data that was unimportant, so I just turned it off. And that was they had a prepackaged Grafana dashboard, which was pretty to look at, but metric server is the new thing. I haven't really dug into it because it hasn't actually replaced Heapster yet. They haven't finished it. It's getting there. Storage is another big thing for how Kubernetes manages things. So normally you make an object called a persistent volume claim. And if you have a cloud provider, it's all easy. You just summon a disk and attach it to a pod or a service. And that's it. You don't have to care about where it comes from. So you can also run Rook or Ceph if you're into these things, just network attached storage. It can do iSCSI, and it can do NFS, and it can do S3 kind of storage, or even Git, which is weird, but it can do it. None of those things run on ARM, and I don't have the hardware for it, so I don't do that. Ceph requires an obscene amount of hardware, and Rook does not provide ARM images. So I just started using the NFS server because it's tried and true, whatever. I'll get into Ceph eventually. Rook is pretty neat. Rook does, you give it a big old disk, and it just provides S3 file storage and file level storage and block level storage, I think. But I couldn't do any of that. So, yeah. Here's more things that I tried that didn't have ARM images. Weave didn't have an ARM image. Kuberouter didn't have an ARM image. Calico is like Flannel, but with network policy. So you can use the Kubernetes API to say, this service can't talk to the network of this service, and this namespace can't talk to that namespace. Super pedantic stuff I didn't feel like doing in my spare time. Here's Rook.io is the one of storage providers that didn't work. Longhorn actually uses the leftover storage on all the nodes and clusters it and does other magic things to make a big generic disk that gets distributed. It sounds super complicated and fragile. This is something that I was really disappointed I didn't get to use. So you probably saw those Kubernetes manifests flying around. Those suck to write. So Helm is a package manager for Kubernetes. It templates out all those things, and you can get official Helm charts and deploy like a Postgres instance using the official Postgres provided Helm chart, and it's like kosher. Everything's cool. It's well written and well thought out, and there's like issue trackers for it, so you don't have to actually worry about being good at writing Kubernetes manifests. However, the thing that actually runs in Kubernetes to do the API actions, Tiller, doesn't provide an ARM image, so I could never use it. I don't understand why it needed a thing to run on the Kubernetes cluster itself. My laptop is perfectly fine at that. So they're getting rid of it. I'll check it out in a couple months. I also spent a lot of time playing with Prometheus. Some guy had their own Prometheus Docker containers, but they were sketchy. So I stopped doing that. That's about it. I didn't really have much time to play with that one. Prometheus is really cool and I like it. And a lot of the services I have built-in Prometheus, like endpoints and whatever, but I never got around to it. Shippable, I don't know if you can see that. Shippable is a CI system. They do have ARM systems available for building images, but I also haven't gotten around to getting that working to actually like make my own images that I trust. I'll get around to it. So now we get to actually talking about the Kubernetes manifest and stuff. Octobox is a GitHub notification management service. It's like an inbox for all your GitHub notifications. My day job is on GitHub, so I have like 100 repos that get a bunch of activity on them, and the GitHub notification sucks. So I found the service, and you get like so many more features from hosting it yourself. So I wanted to host it myself. I also thought it was a good example to try running in Kubernetes because it's like a normal application. It's just a Ruby on Rails container that needs Redis and Postgres in the back end. I learned how to use diagrams in this presentation. Yeah, this one sucks. So for the Kubernetes objects I need to make, you need to make the Octobox deployment object, which is the deployments manage pods. So if you want to actually run a pod in your cluster, you have to attach it to a deployment. And you attach a service to a deployment, and they, like, when you ask for the service, it just magically connects. It's not actually magic. It took me a long time to figure that out too. Type load balancer means it gets a real IP from Metal LB and it gets an IP on the network. The same thing for Postgres, except that doesn't get an IP on the network, it just gets an IP on the cluster. And Redis is the same thing. I actually think I'll go through the Redis one first because it's simple. And then I had to make an Octobox ingress object to configure traffic. So when you receive a web request with octobox.mydomain, then to make sure it gets connected to the Octobox service.